Now, in this question, we have been given a parallelogram ABCD. Now, the point to be proved here is that you have to prove that area of triangle AOB plus area of triangle ODC, that is AOB plus ODC, is half the area of the parallelogram ABCD. So the first thing which you must know is whenever a question is given, when they say O is a general point, you need to make it sure that O has to be a general point. Now don't you take, supposing you draw a parallelogram and you take O as the meeting point of the diagonals. Then you know what your mind will keep thinking? Your mind will keep thinking that these two triangles are congruent and these two triangles are congruent. You don't need to do that. You just take a general point. Now once you get that general point, you are clear that these two triangles are not congruent. Neither are they. Now every theorem of this chapter says it's lying between the same parallels. So every theorem starts with having the same base and lying between the same parallels. So what we need to do here is that we need to think how we can generate those parallel lines. Now how do we generate them here? The construction. We start with the thing. Given there is a parallelogram, O is any point inside, they can prove that dotted triangle AOB and this triangle DOC together, these two are equal to the area of these two triangles. So they are not congruent. One thing is clear. Now we get that parallel line by drawing a parallel line construction. We draw a parallel line parallel to ABDC passing through O. Once we do that, we understand that we get two new parallelograms. So we have a parallelogram ABQP and a parallelogram PQCD. Now, where we can connect it with area theorems? Simple, we take the upper parallelogram. Now we consider triangle AOB. Now when we consider triangle AOB, now make sure here base does not mean that it has to always lie flat. Base also means we can have it at the top. So here AOB is equal to half of parallelogram ABQP. Now that's a theorem. Which theorem? You need to think about the theorem right now. I'm giving you time to think about the theorem. It is that if a triangle and a parallelogram have the same base and lie between the same parallels, then triangle is half the area of the parallelogram. Now the same theorem is repeated here in the second parallelogram, that is triangle DOC. Now where we see triangle DOC, here we have triangle DOC. Triangle DOC is half of the parallelogram PQCD. So this upper triangle is half of the upper parallelogram, lower triangle is half of the lower parallelogram. Now we start parallelogram ABCD. It consists of, you can see here, it consists of 4 triangles. Now these triangles are triangle AOB, BOC, COD and DOA. Now we have these 4 triangles, out of which we have proved that AOB plus DOC. triangle AOB plus DOC. Now here we come back. What we need to do here, we need to add these two. AOB is half of this is half of the upper triangle, this triangle is half of upper parallelogram, this triangle is half of lower parallelogram. Adding them, these two triangles become half of the entire parallelogram ABCD. It becomes half of the entire parallelogram ABCD. Now, as we said, this parallelogram consists of four triangles, AOB and COB. These two, AOB plus COD. AOB plus COD is equal to half. This is what we have proved here. So that means, this simply means that the two leftover triangles, triangle BOC plus triangle DOA, must also be half of parallelogram ABCD. So this also means that the remaining two triangles must be half of parallelogram ABCD. Now since this is half and this is half, triangle AOB plus COD is equal to triangle BOC plus AOD. I am sure you must have followed this.